All right, last lesson in Unit 4, 4.6, talks about similarity in transformations. So two figures are similar, they have the same shape, but not the same size. Or same size is congruent. So similar figures, same shape, different size. Okay, there's a whole lot of words here. A whole lot of words. So dilations are non-rigid motions because they preserve shape, but not size. So a similarity transformation, it is a dilation or a combination of the rigid motions like translation, reflection, rotation, and dilations. So two geometric figures are similar figures if and only if there's a transformation, a similarity transformation that maps one of them to the other. So unlike the rigid ones, similarity transformations only preserve angle measurements, not side lengths. Unless, of course, your dilation is a scalar factor of 1, which does happen. I know it seems very pointless to have a factor of 1, or negative 1. So remember, similar also means proportional. So again, back to the Ant-Man example I used in the past. When Ant-Man shrinks down, he's proportional, right? If he goes to 1/10 of his size, everything is 1/10. He's not going to have 1/10 of his body in a normal size head. He's not a Funko Pop. So it's proportional. So here we're going to graph triangle ABC. It has its vertices, and we're going to apply this transformation here. A translation of x plus 5, y plus 1, and then a dilation of 2x, 2y. So first things first is graph the triangle, connect the dots, boom. And now we're going to translate it. So x plus 5, y plus 1 is 5 units right and 1 unit up. So we'd have A prime at 1, 2, B prime at 3, 3, C prime at 3, 2. So put them there, connect the dots. All right, there's your translation. Now your dilation says 2x, 2y. So A prime at 1, 2 becomes A double prime, 2, 4. B double prime would be at 6, 6. Not 6, 7, 6, 6. And C prime would be at 6, 4, which is a nice normal height that most adults should be at because we're not large, we're just normal sized. So now if we graph that one, there is A double prime. And if you look at it, it's proportional. The side BC on the original triangle is 1 unit tall, right? Well, the B double prime, C double prime is 2 units tall, which is twice the size, proportional. Okay, so now I want to figure out a similarity transformation that maps trapezoid PQRS to trapezoid WXYZ. Remember when it says maps to, it has to match up in that order. So P has to go to W and Q has to go to X. Keep that in your head. So we got some coordinates here. So if you look at QR, XY there, the QR is going down from left to right, and XY is going up from left to right. So they're facing different directions. So first things first, we got to reflect something. So I'm going to reflect PQRS in the y-axis. Whee! So now it's facing the same direction as WXYZ. So now we're facing the same direction. Well, we got to shrink down now. We're going to play Ant-Man. And it looks like it's about a third of the size. And they got that by counting. If you count P prime S prime, that is a distance of 6 spaces. If you count from W to Z, that's 2 spaces. So 2 divided by 6, new divided by original number, is 1 over 3. 2 over 6, 1 over 3. So we're going to dilate that trapezoid, the prime one, using a factor of 1/3. So P double prime becomes 2, 1. Q double prime becomes 1, 1. R double prime becomes 0, -1. And S prime double prime becomes 2, -1. And those match your vertices. So your transformation is a reflection of the y-axis followed by dilation with a scale factor of 1/3. So you're just figuring out what happened. So our coordinate rule, now it gets fun. So first things first was we had to reflect the y-axis. So the rule for that, remember, is -AB. And then we had a scale factor of 1/3. So we just take 1/3 times -AB and get -1/3 A, 1/3 B. So your coordinate rule for the whole thing is A comma B leads to -1/3 A, 1/3 B. See, not that bad. Just got fractions and negative signs and letters. So you can use a composition to dilate a figure when the center of dilation is a point on the figure. And we did this before, kind of, with something. So all you're going to do, you got your triangle here, get your vertices all nice and happy. So you're going to dilate it at point A with a scale factor of 2. So what you're going to do is translate the figure so the center of dilation goes to the origin, like that. We did this a few lessons ago, the translations. So now, that gives you A minus 1, B minus 1. That's your rule. So you define your new coordinates. So A prime is at 0, 0. B prime is at 2, 1. And C prime is at 3, 0. So now we're going to apply the coordinate rule with a scale factor of 2. So we double everything. So A double prime stays at 0, 0. B double prime becomes 4, 2. C double prime becomes 6, 0. You see it there, the big red triangle. Now we're almost done. So we're going to move this triangle back. So apply the rule. So now A triple prime becomes 1, 1. B triple prime becomes 5, 3. And C triple prime becomes 7, 1.